Welcome.
Hello.
Hello. How are you?
I'm doing good, thank you.
You've been working at the Laboratory of Tribology and Interfacial Chemistry with Dr. Stefano Mischler?
Yes, that's correct.
Right? Okay. I'm happy it's you rather than me because I would do it. Anyway, the title of your thesis is Effect of Environmental Transients on the Corrosion of Aged Iron in Inert Porous Media. Je dois éclaircir quelque chose. L'expression que je dis, moi, ne correspond pas toujours à celle qui est là, car vous avez la version pour les nuls, et moi, j'ai la version officielle. C'est presque ça, hein, la réalité. Donc non, c'est une version simplifiée qui est proposée ici, et moi, j'ai la version officielle que je suis obligée de vous dire. Voilà. So that's the title of your thesis. You worked at the Laboratory of Tribology and Interfacial Chemistry?
Yes.
With Dr. Stefano Mischler?
Yes, that's correct.
Are you ready?
Yes, I'm ready. Thank
Great.
you.
Enjoy.
I have a question for you. Do you think the ancient Romans can help us prevent nuclear waste leakage? Surprisingly, the answer is yes. Let me explain how. Today, 10% of the world's electricity is produced by nuclear power, which is carbon-free and almost limitless. However, radioactive nuclear waste is also generated, and currently, this waste is disposed of in steel canisters that are buried deep down under the ground. But what will these steel canisters look like after thousands or even millions of years? Unfortunately, metals naturally corrode when exposed to air, water, or high temperatures, forming scale like the rust we see on our cars. If this scale is left undisturbed, it can protect the iron. But over the years, nothing stays the same. We don't know what effects human and natural activities like farming, building construction, or earthquakes have on the corrosion of this buried iron. These activities could contaminate the groundwater and infiltrate the soil, causing sudden environmental changes that we call transients. If these buried steel canisters get damaged by such transients, radioactive nuclear waste could leak out and get into our water supply, which can cause serious health problems. Remember the Romans I was talking about? 2,000 years ago, they left us countless iron artifacts, which are now buried in the ground, just like those steel canisters. The goal of my thesis is to bridge the past and the future by understanding the effects of environmental transients on the corrosion behavior of aged iron. In our laboratory, we accelerate the corrosion of iron to form scale similar to those found on Roman artifacts. We then mimic the soil using porous membranes. This allows us to study the individual corrosion reaction mechanisms of iron under well-controlled conditions. Currently, we understand the scale formation process in iron and what happens to iron once the scale is dissolved. We are now in place to introduce environmental transients to further gain insights for the prevention of nuclear waste leakage. So, I would like to thank the ancient Romans for leaving so many weapons around that will help us solve many of the scientific issues that we have today and in the future. With the success of our project, we hope to keep our nuclear energy clean and safe, and also to better preserve our natural and historical heritage for future generations. Thank you.